Today, we will be surveying the area surrounding a utility building on the west side of Master Campus, near Parking Lot P, in order to create a contour map of the area. The objectives of this lab are, first, to familiarize the user with aspects of the GPS measurement system. Second, to establish elevations at a finite set of points in a project area using the GPS. And third, to utilize the elevation data we gather to plot a contour map of the area. In this module, we will be reviewing the equipment that we will be using in the lab. In today's lab, we will be using a Sakia GCX2 single-person GPS unit. This GPS unit consists of 3 parts: a receiver for communication with the satellites, located at the top of the GPS rod, a GPS rod for holding the receiver and handheld data unit, and a handheld data unit for data storage and organization. To communicate with satellites, a signal receiver is needed. The receiver is first turned on, and the status of communication is shown using indicators on the receiver. A flashing green satellite symbol indicates communication with satellites is currently in progress. A solid green satellite symbol indicates that the receiver is locked onto the satellites in range. The GPS rod includes a leveling bubble. When the rod is level, this ensures horizontal and vertical alignment of the receiver with the point we wish to measure on the ground. The communication with satellites identifies the position of the GPS receiver only. If the GPS receiver is directly above the measured point, then we can be certain of the horizontal position and elevation of that point. The horizontal position of the measured point would be the same as the GPS receiver, and the elevation of the measured point would be the elevation of the GPS receiver minus the height of the rod. To properly use a leveling bubble, a steady stance with feet shoulder width apart is recommended. The tip of the rod should be firmly planted on the point that is to be measured. The rod is gradually moved in order to locate the air bubble within the target circle, as demonstrated here. This process is very similar to that used when holding the prismatic reflector during the ADL traverse. The handheld data unit is used to organize jobs and store data from in-field surveying measurements. The unit used in this demonstration is an Archer 2 unit from Juniper Systems. Your GPS equipment will include a similar unit, though the steps may differ to what we are doing here. Several steps are needed to prepare the unit for surveying.
The Archer 2 unit is connected to the network through the modem. Now we're going to open up the Magnet Field Surveying app. The first thing the app will need to do is connect with the satellite receiver on top of the pole. Okay, so the first thing that it will need to do is connect to the receiver. So we'll hit connect. The next thing that needs to happen is that we need to connect the receiver to the network, and that's what's happening here. So from the home screen, we'll create a new job, and we will give it a name. So okay, once the job has been created, then we can go straight into the surveying. We hit the survey tab and then topography.
Now there's several things to note here from the total station, from the GPS unit itself. Here, it's giving us how many satellites it's actually communicating with. So here it's actually, you can see there's an 11 plus 11, so it's actually locked in to 11 satellites and can see 11 other satellites at the same time. This over here indicates that the solution is fixed. Where it says green fixed, it means that it has enough information available to it to be able to come up with a solution for exactly where we are on the face of the Earth. And these numbers here, this H and V, are giving you the sort of the range of error, or what it thinks is the range of error for the horizontal, meaning the XY plane, and the V meaning the vertical plane. And very typically you can see that the error for the vertical plane is about twice as much as that of the XY plane, which is very typical for GPS. Down here we see actually a live readout of the north coordinate east coordinate, and elevation. And that's a constant live readout, you can see there. If you focus on the elevation here, you can see how much the elevation is changing. Even though we're fixed, it's got a range of change of about 5, 6, 10, oops, just get that screen up again, about 10 millimeters, just even while we're sitting here. While we're here, what we're going to do is actually save this point. So all I'm going to do is hit enter, and it saved that point. Now that point is stored in memory. If I want to take another point, obviously I'm just going to move to wherever I want to be, and I'm going to wait for it to have communicated to its satellites and attained its fixity.